Hey, McLaren here with McLaren again. We're going to be going over something called the distributive property today. Sorry, I'm a little sick right now, but hope you don't mind. It's just kind of one of those things where it's like I'm too sick to really teach in my class, but I'm well enough to speak softly into the mic and do this, and I've been wanting to do this for a little while. So I wanted to talk to you about multiplication with something called the distributive property. It's incredibly useful. And it's something that is actually built into what we usually do with multiplication, but we represent it a little bit differently when we're doing multiplication of large numbers. So right here I've got this grid set up for 7 times 18. So I've got 10 blocks here in green, and then another 8 here in yellow, and then I've got 7 right here in yellow as well, as you can see. So I want to use this because it's kind of like graph paper, but it's kind of nice because we've got these color coordinations. Usually when you do multiplication, you multiply the 7 by the 10 and you get 70. Sometimes it's written as a 7 in the 10's place, but sometimes it's written as a 70. There's multiple ways to show this. I might show some of this off to the side actually. If I can get 2 videos going at the same time. So we've got that 70 there, right? Then we've got 7 times 8, which gives us 56. And I just wanted to kind of show you this right here, this square is that 7 times 10, which is 70, and this square right here is the 7 times 8, which is 56. So if we've got the area of this rectangle made up from this edge and that edge, and the area of this rectangle made from this edge times the 7 edge as well, we can then add those two numbers together and we should get this big rectangle, which you can pretty easily visually see, right? So you get 126. So that's how we usually do multiplication of large numbers, but you can also break this up a number of different ways, and through something called the distributive property, where you're distributing the sides and the multiplication, you can easily do this. So we can take the exact same area, got our 7 by 18. Instead of breaking up that way, what we can do is we can maybe break this up into 2 pieces, because maybe 8 times 7, you have a hard time with that. Well, you could do the 7 times 5, which gives you this 35 here, and then you've got your 7 times 3, which gives you 21. If you add those two together, you get 56, right? So you can then add up all 3 numbers and you still get the same total area. Because this is the same total area, and I've just split this up a little bit differently, it's still equivalent, right? You can see 1, 2, 3, 4, 5 there, and then you got your 3 here. And you can also do the distributive property, but you can subtract pieces off. So maybe you're like, oh, well, 7 times 18, it's pretty close to 7 times 20. So if I had another 2 rows here, that edge had been 18, but if I add another 2 rows, it's 20. And so I know all these blue squares is the 7 by 20, which is 140. But I want to subtract this piece right here, the 7 times 2, 14. So I can then look at this and say I've got 140 minus 14 also gives me 126. And we can do this on the other axis too. So maybe you've got 7 here, but you want to make it 10, because it's just 10s are easy to work with. For me, the numbers that are easiest to work with are like 5 and 10 and like 2. So if you make this 10 long, now we've got 18 times 10. So we've got the 10 and the 18, which gives you 180. But then you want to subtract this area right here, and you can just do the whole thing, which would be 3 times 18, or you could break it up into 2 different chunks. So if you've got 3 times 10, that's going to be 30. And then the 3 times 8, that's 24. So 30 and 24, if you add those up, you get, what is that, 54? And if you subtract that from the 180, you should get 126. looks like that works out. That was not me jumping for joy, that was me trying to hit my space bar and it didn't really work. Okay, so we got also... Okay, this one is something that I've seen a lot with the online math curriculums, is they create these arrays where you have like 4 different ones, you gotta add them up. So this one, we've got our 5 by our 15, which is, like I said, 5s are not too hard for me. So 75, got that. Then you've got our 2 by our 15 here, which you have 30. And then you've got our 2 by 3, which is 6, and our 3 by 5, which would be 15. Same number, right? If we look there, I combined those first 2 numbers, got 105. Combined these 2, I got 21. Still 126. Now this one, I actually didn't write out the work, but you can see that we've got our 7 by 6. So if we look at 7 by 6, that should be equal to 42. I just remember that because, it's the meaning of life, right? And then we actually have 3 sets of this. So 1, 2, 3, 4, 5, 6. So this is another 6 by 7. So that's also 42. And then this is also by 6. So we could have essentially 42 plus 42 plus 42, also known as 42 times 3, which would give me 126. So you can split up these edges, as long as you do the multiplication of the edges, all of them, by the original other edge, you should be fine. So for example, I've got our 7 times 6 plus 7 times 6 plus 7 times 6. That's the same thing as 7 times 18, aka the distributive property. So if we have, let's take the last example that we were looking at there. If we had 7 by 6s, I believe the line would be right there and right there. So we've got these edge lengths of 6 for each one of these guys. And we've got this 7 here for all of these edges. What we can do, the distributive property, usually how it's taught is, well, you've got this times that, and that's the same thing as 7 times 6 plus 6 plus 6. So the distributive property is usually taught like, well, this is equal, so what you need to do, if you're going to multiply 7 by 6, you need to multiply it by all of these guys to distribute that edge length. But you can see what you're basically saying is, if I've got this length here, I need to multiply each one of these widths here to get the total area. Because it doesn't make sense just to do 7 times 6 on the first one and not these other 2 that are right here. Because, well, those are still edge lengths on our area problem. So you can see with the distributive property that, well, if you're going to split up the edge, you need to multiply the whole thing, not just pieces of it. So you can say that this is the 7 times 6 plus 7 times 6 plus the 7 times 6. So that was the last problem that we looked at. We've got the distributive property, which we use to split up the number, and then there's something called, oh gosh, what's it called? It's not foiling. No, it's the distributive property. Yeah. Okay, so why don't we go ahead and look at another problem. Let's just kind of undo all that. Okay, so let's say we were looking at the one that we did the subtraction on. So if we had this little extra chunk on here, we had so we had 7 times 18. I'm just gonna actually move this down a little bit and see if it lets me. There we go. Okay, it looks like, no, it won't let me move out. It'll just let me zoom in. Okay, well, that'll work. So we got 7 times 18, which is the same as 10 minus, was it 3 times 18? So if we're gonna do this multiplication, we need to distribute the 18 by these two different numbers. So if we have 18 times 10, that's the first one, minus, because remember we want to get rid of this whole chunk here, 3 times 18. Then we would have the 180. This is being kind of tricky now because we're on the bottom of the page. We got the 180 minus the 56, or 54. And that would give us our 126. Okay, so that's the distributive property shown with 2 of the examples of what we just looked at there, with how to visually split up a number to do multiplication. Just kind of showing the more formal way of how we would look at the distributive property. Usually we think of it as like have a one-way kind of thing, like you go and you distribute the number out, but you can also split the number up, which is kind of like what we were doing, visually splitting up the number and then piecing it back together to get that area of the 7 by 18. Let me know if you got any questions. Thank you for joining me. This has been McLaren with McLearn.